The day longer than the year. Venus turns very slowly, and it turns the wrong way. One full rotation against the stars takes about 243 Earth days. One full orbit around the Sun takes about 225. So on Venus, a rotation takes longer than a year. The rotation is also backwards. Almost everything in the solar system spins in the same direction, the direction it orbits. Venus does not. Seen from above the solar system, it turns the other way, which means that on Venus, if you could see anything through the cloud, the sun would rise in the west. There is one more twist. Because the rotation is slow and backwards and the orbit is quick, the time from one sunrise to the next is not 243 days. The two motions partly cancel. A single day to night to day cycle on Venus takes about 117 Earth days. Why it ended up this way is not settled. The leading explanations involve the thick atmosphere and tides from the sun acting over a very long time, and possibly a large impact early on. This is one of the places where the honest answer is that we do not know yet. 3 turns 2 years. Mercury is locked to the sun, but not in the way the moon is locked to us. The moon turns exactly once per orbit, which is why we see one face. Mercury turns exactly 3 times for every 2 orbits. It is a different lock, and it is stable for the same reason. The planet is not a perfect sphere, and the sun's pull settles it into a whole number rhythm. The consequence is strange. A rotation against the stars takes about 59 Earth days. A year takes 88. But sunrise to sunrise takes 176 Earth days. Exactly 2 Mercury years. So a day on Mercury lasts 2 of its years. There is a further oddity. Mercury's orbit is stretched, so its speed around the sun changes a lot. Near its closest approach, the orbital motion briefly outruns the rotation. From certain places on the surface, the sun would rise, stop, move backwards for a few days, stop again, and then continue. We did not work this out from the ground alone. Radar measurements in the 1960s overturned the earlier assumption that Mercury kept one face to the sun, and the spacecraft that followed confirmed it. The mountain you could not see. Olympus Mons on Mars is the largest volcano in the solar system. It is about 22 kilometers high, roughly 2.5 times the height of Everest above sea level. But the height is not the interesting part. The width is. It is about 600 kilometers across. That is wide enough to cover a large country. And because it is that wide and only that tall, the slope is very gentle, around 5 degrees in most places. Walking up it, the ground would feel almost flat, which produces a strange result. If you stood on the flank of Olympus Mons, you would not be able to see that you were on a mountain. The summit would be far over the horizon. Mars is smaller than Earth, so its horizon is closer, and the whole structure is far too large to take in from the surface. The edge is different. The volcano does not taper away gradually at its boundary. It ends in a cliff, in places several kilometers high, running around much of the base. It grew so large partly because Mars has no moving plates. On Earth, a plate slides over a hot spot, and you get a chain of islands, each one built and then carried away. On Mars, the ground stayed put, and everything piled up in one place for a very long time.